Hello and welcome to lesson 5G. I can identify the properties of a rectangle and prove that a quadrilateral is a rectangle. So a rectangle is a quadrilateral with 4 right angles. This makes a rectangle a subcategory or another type of parallelogram. Okay, and a rectangle is considered to be equiangular because all 4 angles are congruent. Furthermore, if a figure is a rectangle, then the diagonals happen to be congruent as well. So let's mark on here what our rectangle is going to look like. I'm going to draw on my diagonals. Okay, I know each of my angles are going to be 90 degrees down here. I know that my diagonals are congruent, so I'm going to go ahead and mark all of them like that. And we've got the same properties as a parallelogram, which I'm not going to mark on here, but you guys could figure out on your own. So we should all be very familiar with rectangles in general. So you can prove that a quadrilateral is a rectangle by 2 methods. First, you can prove that all 4 angles are congruent right angles, or just congruent angles. That's my definition. Or you can prove that the quadrilateral is a parallelogram and that its diagonals are congruent. You need both for that one because we have other types of quadrilaterals with congruent diagonals. So just be aware of that. So just like with the rhombus, these proofs can be broken into 2 pieces. You're first always going to prove that the thing you have is a parallelogram. Then the second thing you're going to do is you're going to prove that it's a rectangle, right? And let's take a look at the one they give me here. In this one, they tell me that angle K and angle L add to 180, and angle K and angle J add to 180. Well, that's going to help me prove that we have a parallelogram because angle K is supplementary to both of its consecutive angles. Okay. Then they tell me that angle K is equal to angle L. Well, this is going to allow me through a whole lot of use of transitive property to prove that all my angles are congruent, which will allow me to prove that it's a rectangle. So this is kind of the plan for this proof. So let's take a look, guys. In my hint, write small. I don't think I gave you guys quite enough space on this one, so give yourself a lot of space and write small. Okay, sorry in advance. So as always, we have our statements on one side and our reasons on the other. And let's take a look. I'm going to start off with the first 2 givens only. Measure of angle K plus measure of angle L equals 180. And the measure of angle K plus the measure of angle J equals 180. And my reason is given. Well, that allows me to prove that JKLM is a parallelogram. And again, I'm going to use my cute little shorthand, parallelogram, because angle K is supplementary to both consecutive angles. Okay, so we've got that this thing is a parallelogram. My other given is that the measure of angle K is equal to the measure of angle L. That means that they're also congruent. Angle K is congruent to angle L. That's definition of congruent. Well, if things are parallelograms, then their opposite angles are congruent. So that means that angle K must be congruent to angle M, and angle L must be congruent to angle J, because opposite angles of parallelograms are congruent. Okay. And then I'm going to get everything related to K like I did before. I know K is congruent to L, so I can then say that angle K is also congruent to angle J by the transitive property. Oh my gosh, what is this thing doing today? Sorry guys, bear with me. By the transitive property of congruence. There we go. Therefore, I'm going to do a little bit of a cheat and say angle K is congruent to angle M, which is congruent to angle L, which is also congruent to angle J. That's a major cheat with transitive. Well, that just shows that all of my angles are congruent. Therefore, JKLM is a rectangle. Oh, please write. I'm sorry, guys. I promise this is the computer. Rectangle. That is awful because all 4 angles are congruent, which, by the way, is also our definition of a rectangle. Cool. All right, guys, thank you very much. Go ahead and take a look at the MML and we'll see you in class.